Howdy AGP students, this is Chris Crouch, your SAT math instructor. During this session, we'll be covering the trial and error math strategy. This is an exciting strategy that some of you may already know about. Unlike the algebra problems you've had in the past, the answer is staring right at you in the answer choices. You may be asking yourself, how do I know what a trial and error problem looks like? First, the problem will ask you to solve for a variable or something. This could be anything from the number of cars passing through a toll booth, or as simple as solve for x. In either case, you will be required to find an unknown value given some information. We'll now look at some general strategies for these types of problems. First and foremost, we love trial and error problems. With these problems, it's okay to be wrong, and in fact, we will be wrong. The way that we're going to implement this strategy, we're first going to start with answer choice C. This is really important. The SAT arranges their answer choices from least to greatest, starting with A and ending in E. By choosing answer choice C as our starting point, we eliminate 60% of the answer choices from consideration if C is not the correct choice. Now plug answer choice C into the original problem and evaluate the expression. Remember, when you evaluate the expression, use your calculator. There's no reason to miss a problem because of an avoidable math error. If the answer choice results in a true statement, choose answer choice C. This is the correct answer. Otherwise, evaluate the result. If plugging in C resulted in too low of an answer, you may need to choose D or E. This can be tricky, as we'll see in one of our examples. Now, if C was incorrect, choose one of the remaining two answers and evaluate the expression again. If this choice is also incorrect, and your result increased or decreased as you expected it, the correct answer will be the remaining answer choice. Properly using this strategy will allow you to only evaluate the problem twice. When you encounter a word problem, make sure you read the problem slowly and carefully. Ensure you understand exactly what the question is asking. You may need to draw a picture or write out the given information in a concise manner. Above all else, make sure you fully understand what the question is asking. We're now going to transition to our first example problem. In this example, we'll use the trial and error method to solve for x. Here, we are given an equation and a limitation on the answer. In this case, 2 subtracted from the product of 2 and x, quantity squared, equals 64. Additionally, x must be greater than 0. We'll begin by plugging answer choice C into the original equation. Answer choice C was 6, so we'll insert 6 for x. Here, 6 times 2 minus 2, quantity squared equals 64. So we'll go ahead and use our calculator and multiply 6 times 2. That'll give us 12. Then we'll subtract 2, which gives us 10. And we can see 12 minus 2, quantity squared equals 64. 10 squared equals 64. Now, you and me both know 10 squared is not 64, but we'll go ahead and use our calculator and get the answer. And 100 definitely is not equal to 64. Since when we plugged in answer C, our result was higher than 64, we know that we need to lower our input. And we'll do that by choosing answer choice B. Answer choice B was 5, so we'll plug in 5 for x. Again, we'll get out our calculator, multiply 5 times 2, and we get 10. So 10 minus 2, that's going to equal 8. So 10 minus 2, quantity squared equals 64. 8 squared equals 64. Now that seems more right. Let's go ahead and double check that with our calculator. And sure enough, 64 does equal 64. In this case, you'll bubble in answer choice B and you'll be done with the problem. Move on to the next. That brings us to our second example. In this example, we have the quantity of x minus 2 squared equals 49. X could be A, B, C, D, or E. And again, you'll notice the answer choices are arranged from lowest to highest. Since this problem has a variable, we'll use the trial and error method. Again, we'll begin with answer choice C, which was 2. So we'll substitute in 2 for x. In this case, 2 minus 2 quantity squared equals 49. So we'll get out our calculator. 2 minus 2, that's going to equal 0, and 0 squared is 0. So you'll see 0 does not equal 49. Because 0 is less than 49, we'll increase our input. So we'll try answer choice D. Answer choice D was 5, so we'll substitute 5 in for x. We'll pull out our calculator and subtract 2 from 5. That'll give us 3. So now 3 squared equals 49. Well, that doesn't seem very right. So sure enough, 3 squared is 9, which does not equal 49. At this point, we can see that when we increased our input, our output also increased. So we know that we went in the right direction. And now we know that we have eliminated all the answers except answer choice E. So at this point, we know that answer choice E is the correct answer. Just to reinforce this, we will actually work this problem out. Now, on the SAT, I don't expect you to work this problem out. You should actually stop here and bubble in question E. But just for the fun of it, we'll work out answer choice E. So answer choice E was 9. And if we get our calculator out, 9 minus 2, that equals 7. So 7 squared, that looks a lot like 49. And sure enough, 7 squared is 49. So E is your answer choice. Now I'd like for you to look at problem number 3. And I'd like for you to pause right here and try to work this out on your own. This will actually be in your workbook, and you can actually use the trial and error method to solve for example 3. And we'll be completing this problem in class, but if you have a chance now, go ahead and work this problem out using the trial and error method. Remember, the more you practice these methods, the better you will be at them. Now we'll move on to some word problem examples. So our first word problem example reads, the sum of 4 consecutive integers is 82. Find the greatest of the 4 integers. Now this may seem like a really hard problem, but the answers are looking at us right in the face. And so again, we'll start with answer choice C. Because answer choice C is 21, we'll just add 4 integers, 21 being the largest. I like to start with 21 since I know that's going to be my largest, and then decrease. So 21 plus 20 plus 19 plus 18 equals 82. So we'll get our calculator out and we'll add these numbers real quick. And we'll find out that indeed these numbers do not add up to 82. So again, we know 78 was less than 82, so we should increase our input. So let's go ahead and try answer choice D. And D was 22. And so we'll get out our calculator again. We'll use the same idea. We'll start with the highest number and then go down. The 4 consecutive integers, 19, 20, 21, and 22, those are consecutive. So we'll go ahead and add those. 22 plus 21 plus 20 plus 19 equals 82. Indeed, 82 does equal 82. So answer choice D is the correct answer. Go ahead, fill in the bubble, and proceed to the next question. Example 2 reads, on a certain bridge there is a toll of $3 for cars and $5 for trucks. From 50 vehicles, all either cars or trucks, a total of $210 in tolls was collected. How many of the vehicles were cars? So this question has a little bit more information. And we know the question is asking for, of the 50 vehicles, how many were cars? So because we know that each car was charged $3 and each truck was charged $5, we can set up a little equation. So we'll choose answer choice C to set up this equation. Answer choice C was 25. So if there are 25 cars and 50 total vehicles, that means that there were 25 cars and 25 trucks. And because each car was charged $3 and each truck was charged $5, we can set up the equation below. So 25 cars times $3 plus 25 trucks times $5 equals $210. So we'll get out our calculator and see if this is correct. So we have 25 times 3, and that equals 75, and then plus 25 times 5, which equals 125. So you can see that here, 75 plus 125 equals 210. So we'll add 75 and 125, and we'll get 200. And what do you know? 200 is not equal to 210. Here, if we increase the number of cars, that will actually decrease the total value of this problem. In this case, we'll need to have less cars and more trucks to increase the overall answer. This would eliminate answer choices D and E and leave answer choices A and B as the only two viable options. We'll go ahead and choose answer choice B, which was 20 cars. If there are 20 cars of the 50 vehicles, that means there's 30 trucks. So we'll set up this equation: 20 times 3 plus 30 times 5 equals 210. So we'll first look at 20 times 3, and that equals 60, plus 30 times 5, and that equals 150. So we'll add 60 to 150, and that'll give us the answer 210. And indeed, if 20 of the cars paid $3 and 30 trucks paid $5, we would receive $210 in tolls. Next, we'll take a look at example problem number 3. I encourage you guys to go ahead and take some time, do this problem. We won't do it here on the video, but we will do it in class. So have a good day. Until next time.